Welcome, my name is Richard Cooper and I am the President and CEO of NYSpin. I would like to thank our sponsors. Big Visible has been a sponsor for several years and we greatly appreciate their support. BPM Institute is one of tonight's sponsors. Is it HAVAS or HAVAS? HAVAS. HAVAS Worldwide, our gracious host this evening. Brian Berenbach last presented to us back in November of 2007. His topic at that time was software process improvement through best and emerging requirements engineering practices. Quite a mouthful. We are pleased to welcome Brian back this evening, this time to tell us about a visual language for requirements engineering. So without further ado, ladies and gentlemen, Brian Berenbach.
Thank you. So what I'm going to be talking about tonight is something which is near and dear to my heart and which I've been working on since about 1985. When I first worked actually with Denise on simulators for nuclear power plants. And the requirements were incredibly complicated, hard to visualize, and difficult to get a handle on. So the topic for tonight is going to be a new visual language for requirements engineering. Different lawyers have their own language, and very often doctors have their own language, and requirements engineering people, by God, we're going to get our own language now. So that's what I've been working on. And so the way I'm going to do it is I'm going to start. First, I'm going to introduce you to my company, because in order to have a perspective on what I do and why I needed this language, you need to understand a little about my organization. And then I'm going to give you 4 stories, situations, all of which actually happened to me, where there were problems with existing tooling for capturing requirements for products and systems, and why we need this new visual language called the Unified Requirements Modeling Language, or the URML for short. That is a mouthful, I know. Then I'm going to give you an overview of the URML and show you what it looks like. And then we'll talk a little bit about its feedback. Naturally, these things are meaningless in a laboratory. You have to use them on real projects to see what their value is and whether they're worthwhile or not. And then if we have time left at the end, I'll actually do a demonstration for you. The way that I normally give talks, if it's possible, is I'd rather you ask me questions as soon as you have one, rather than waiting till the end. I know some people like to wait till the end, but once we're 4 slides down, it may have faded from my memory. So I'd rather you just ask me a question if you have one as we approach the topic. Okay. Okay, and then finally, questions and answers. So first I'm going to talk a little bit about Siemens. Everybody's heard of Siemens. Is there anybody here who's not heard of Siemens Corporation? No? Okay, and that's not the furniture company. That's, that's the company that makes trains, and we make healthcare systems, and we make wind engines for energy, and we make all kinds of good stuff. We're organized in 4 sectors, and I work across all the sectors, which is another reason why I needed this language. I work in industry. An example of industry is we build light rail vehicles for cities and towns in the United States. We build high-speed trains, mostly in Europe. We're building all the high-speed rail lines for Russia right now. In energy, you may know us by another name, Westinghouse Corporation. We make gas turbines that are used to power your appliances. And in healthcare, we make all kinds of imaging products, including MRI equipment, X-ray equipment, and other types of medical devices. We do medical software. Personally, I've worked on emergency room software, operating room software, and so on. So I've worked across the board. Our sales are typically about, for Siemens, about 74 billion euro a year, which runs to over 80 or 90 billion American dollars. And we're in 190 countries, and we have over 400,000 employees. So I'm just one of 400,000. So hopefully it's easy to hide. Anyway, we have 28,000 engineers, and we have lots and lots of inventions. We file patents. We're always filing patents, and I just got 3 this year. So anyway, I'm part of corporate technology, which is one of the branches of Siemens that cross-cuts all the other branches. So I provide services to all of the major operating companies, and my organization, which is corporate technology, has 3 missions. The first is to secure the company's technology and innovation base, and we do that by going out, doing conferences, keeping track of what's going on, and making sure that Siemens is always up there with the latest and greatest. And also looking forward-looking into the future and making sure, or assisting in making sure that we always will, in 5 years from now, we'll have the products that the market needs in 5 years from now. Just to give you an example, corporate technology, we're the ones who do all of the imaging systems for the Siemens medical devices. So if you've ever seen those 3D medical images floating around, and also for those of you who may have an occurrence, we also do this very nice thing called a virtual colonoscopy that you do with an MRI that saves you the need of getting anesthesia and going to the doctor and all that good stuff. So we do that kind of stuff as well. And we support Siemens across the board as an integrated technology company. That is, if we're working in one area and we see something useful, we help to transfer it to another area. Because the Siemens companies by themselves tend to operate in silos. And one Siemens company won't know what the other one's doing, and so our job is to make sure that there's a transference of best practices across the various Siemens companies. So that's basically what we do. And here's corporate technology, and you can see we have lots and lots of different areas where we work. We're across the board. And I am over here in systems engineering. And because requirements engineering is considered to be, for any of you who studied it, the first part of the life cycle for systems engineering. Now, for those of you who don't know the difference between systems engineering and software engineering, systems engineering is the entire product or set of products, including all the hardware and all the software and the integration of all of the pieces, whereas software engineering just focuses on software components. So we're upstream of the decisions as to whether something will be hardware, software, or firmware. Sometimes it's hardware, sometimes it's software, sometimes it's firmware. And I'll show you one of the projects that I worked on that was like that. Okay, so now I'm going to talk a little bit about my own experience in four different situations. Actually, I think there's 5 in there. And, whoops. Put there. There's an ink line. Okay. So anyway, why we need the Unified Requirements Modeling Language. So I'm not going to go back in time to 1985. I'll stay more recent than that. So the first story is, oh, you have a product line. I have on occasion walked into various organizations and people say, well, we have problems with our requirements, with our systems, with our processes. And I'll look at their stuff and I'll say, do you have a product or a product line? And they look at me with blank faces and they say, what's the difference? And so then I have to go through the process of explaining the difference between a product line and a product suite and a product family. A product suite is when you have a washer and dryer and the 2 products are separate and they play together. And you buy both of them like Microsoft Office and then the pieces work together. A product line is like a line of cars. You don't go into a store and say, give me your convertible and give me your hardtop because I'm going to drive both of them at the same time. You go in and you buy one of them. So that's a product line. Customers will pick one of the line. Okay. The second story I'm going to talk about is why is this feature in this product? This is concerning where I will go to an operating company and I will look at the product features and I will say, why is this feature in the product? And they will look at each other and will say, well, we're not really sure. And then I'll say, what are your business goals? And they'll say, we don't know, what's a business goal? And then I have to go through the whole thing about what a business goal is. And then it gets back to, well, we're not really sure if we have any business goals. We'll have to get back to you on that. And so that has actually happened to me at some companies. And the last one is, where are the requirements, you know? Build first, requirements later. Right? And that happens too. Third, we work on many, many products that involve people, and they involve safety. And very often, the current processes for determining whether a product is safe or not safe are inadequate. So the way it typically works is you basically get a set of requirements, you hand the requirements off to a safety expert, or you hand the design off to a safety expert, looks at them, determines if there's any issues, does a hazard analysis, and then gives you the all clear, or you have to put in mitigating requirements. But that's done at the back end. You're not talking to the customer anymore. You're not talking to the analysts anymore. You're not talking to the designers anymore. Maybe you got to go back now and change some of your products. The difference between a hazard and a threat is that a hazard is something that may affect a person's physical health or may kill people if not mitigated. A threat is something that will impact things like identity theft, personal assets. It might involve loss of finances, or it might involve real estate. Your house might come tumbling down, but hopefully no one will be in it. So that's the difference between a threat and a hazard. Threat involves loss to property, personal identity, but not to individual health. Okay. And last, I can't tell the processes from the use cases. We've been using these languages like UML. And UML and SysML, anybody know what SysML is? It's a SysML, SYSML. SysML is an offshoot of UML. The original UML language, Unified Modeling Language, was designed for designing software. The hardware people took one look at it and said, we can't use this. It doesn't have any place to put requirements, right? It doesn't have any space, and it doesn't have any place for defining hardware ports, flow, electrical flow, things like that. So they came up with a variant called the SysML. And so now the UML and SysML are both standards. However, for our domain, which is requirements engineering, neither of them work very well because they were focused on design. They didn't focus on the requirement space. Okay. Is this working? Yes? Okay. Okay. Okay, so I went to one organization, and this was in California. This should look familiar. Does everyone know what the UML is, or does this not look familiar? This is this is from the Unified Modeling Language. Let me just briefly walk through it with you. I assume you can you read it okay? Is it clear enough to read? A little small, okay. Nothing I can do about that. Here's a product line, and here's solutions, a work group product, an enterprise product, an embedded product. And here are some requirements of the product. And here's data manipulation, including data computation features, condition checking features, and data conditioning features. Okay, so I went to this company in California, and I sat with them, and we were supposed to be capturing requirements. And I got past the first 5 minutes, and I said to them, you have a product line. You're planning on building a product line. Because what they had was they had a toolkit, and they wanted to reverse a product line from the toolkit. That's normally the way it works. You start with one product or a set of things, and then you reverse engineer a set of products for the market based on your one success. And that's what they wanted to do. And what they did is they did dashboards for oil and gas. In other words, like Mobil Oil, Texas, Exxon, what they would do is create dashboards that would show a company at any given time how much oil is on the is in the refinery, what's the current price, what's sitting in the middle of the ocean in a boat, and they would actually go in real time into the refineries. So they had a toolkit, and everything was custom, and they wanted to standardize it because their profits were relatively low, and they wanted to also possibly sell it to other marketplaces. So we started working, and very quickly I realized they did not have a product. I was not going to help them capture the requirements because they had a product line. And so I said, well, let's define the products in your product line. So we started to do this. But I ran into a problem. The problem was that this language, the URML, is not suitable for defining a product line. It has no way, for example, to say, well, if a person buys a car, they're going to get either an automatic or a manual transmission. It has no way to do that. It has no way to describe variation points that you can give over to manufacturing and say, a customer might buy it with this or they might buy it with that. So we did the best we could, and they struggled on to figure out whether or not they really had a product line and how they were going to do it. And they said, don't call me, I'll call, you know, don't call us, we'll call you. And then we went back, and I realized that I did not have anything to capture the nature of a product line in the same tool that I was using to capture requirements. That's story number one. Is this working? So we had a product, and we have features in the product. And I had no way to capture them effectively except to use the URML in a way that it was never designed to be used. So story one, what comes out of story one is that the customer expresses whether he can profit from commonalities in existing products. And the reason for building a product line is that you want to take products and you want to standardize on the components of those products. So if you have a line of Chevrolets, you're going to use the same transmission in all of them. And so we need to model various product lines, and also we need to model the features in those products to be able to capture variation points. Maybe I'm too far away. So this is what they needed. What they needed was something, I have to work, is this working? That captured products. So here we see a product line, and here we see the products in the product line. And I wanted to be able to capture the features. How many of you are familiar with feature modeling or product line engineering? Any of you at all? Okay, so I'll walk you through briefly what this is. Okay, so this circle here is, when it's hollow, it's an exclusive OR, meaning one or the other. So you tell manufacturing the customer will be getting this or this or this, but not all three, right? Or you can't order 2 or 3. If this was a solid OR, that would mean that the customer can order 1 or more of them. Hollow indicates optional and solid indicates mandatory. So what this is saying is that the customer can order none or 1 of what we're looking at here. Okay? So that's called feature modeling, and it's a part of product line engineering. So we need this in our traditional everyday modeling tool for capturing processes. So I can tell if a client has a feature and I want to pass it off to the designers that the customer is not going to be buying both an automatic and a manual transmission for his car. He's going to be buying either an automatic or a manual transmission for his car. Okay. So, so here for story 2, here are the stakeholder goals. Let's follow along. Joe says we need high market share and we need lower life cycle costs than we have today. And Mary says we really need a competitive feature set, and and it has to cost less than $150,000 a unit. This is stuff start to sound familiar to you, right? Sound familiar? And we need a reduction in complexity. And John says, yes, but we need packaged options and we need high reliability, right? And you're sitting there writing feverishly if you're trying to capture all of this. And Tom says, well, maybe we want a reduction in complexity compared to the current unit, right? And the marketing manager says, these are all great ideas, let's go with them, right? And then all hell breaks loose, right? When you try to do all that. And engineering says, what? So we need a better way, and that better way is called goal modeling, which has been around for a while, but has not been used very much in the industrial world. So from story two, we get that the customer wants to know how many of his goals can be addressed. And he wants to know which parts of the new product address which of the goals, right? So I can say, why is this feature here? And the customer wants to talk about features of the new product, and so the system shall support feature modeling. So again, you can connect the goals to the various product features and say, now you know why this feature is in your product. Okay, so here is a goal model, and a goal model does things. Let me just back up one, get out of there, you. Okay, so here we have high reliability, but we see that high reliability negatively impacts the cost of a product, including labor, which we want to be less than XYZ euro. This has been sanitized, by the way, because this is from a real product. So we had to do a little sanitization to show it to you. And we want a reduction in complexity of our delivered product, but if we manage to package the options and give the client a limited selections of which options they can get, that will go a long way towards reducing the complexity of the delivered product. We want a competitive feature set, that's negatively going to influence the reduction in complexity. And we want, for example, the average customer price. And if we can get the cost of manufacture, including the cost of labor, below a certain value, then that's going to positively influence the cost of the realized price. Now, there's two ways to make these graphs. One way is to use the symbols ++, which means makes, plus, which means supports, minus, which means detracts from, and minus, which means breaks. Or you can put numbers in. And if you put numbers in, you can then actually go and use an algorithm and do a computation to determine which of the features or which of these goals you're going to be able to meet, given the dollar cost of the implementation of each of these goals. So the idea is, instead of something being just a wish list, you now have a visual way of looking at the impact of these different goals on each other. And so this is useful to have, and it helps to focus management on, and it shows them that when they do want to do one thing, it's going to detract from the other. If you want this, it's going to negatively impact this, as opposed to someone in engineering just going up to management and saying, well, I don't know about it. So up front, it's going to help them.
No question here.
Yes.
On this side.
Oh, okay.
Some of those goals seem to be mapped to specific stakeholders.
Yes.
Some of them seem to be free-floating. Is
Yes.
there any significance to that?
Not at all. It was the ones that are free-floating, the ones where I neglected to capture who asked for them. You can chalk that up to me not paying attention. I might have been off in the corner having a cookie at the time that the person stated that, so I don't know. But your point is well taken, right? But we want to know who specifically wants the goal. So if you open up a goal and you right-click and open it up, you should see who the requester is. Yeah. Yes.
If you do a really thorough job of this, don't you get a very cluttered two-dimensional representation of all these different targets, like one on top of the other, like lining up with? If you knew what that line of targets that you don't know who the stakeholder is, if you really knew who the stakeholders were, wouldn't they be on top of the other targets you have? So it's hard to represent.
That's a very good point. You see this little set of eyeglasses over here?
Yeah.
That explodes to another lower level diagram. So this is a model, and the model is, so this opens up, and underneath you'll see all of the goals that contribute to a break the competitive feature set that are encapsulated in a discussion of a competitive feature set. So it's like any other model. You don't put everything on one two-dimensional surface. You compartmentalize and you take one symbol and it represents a lower level diagram. So you will see this later on. By the way, this is not part of the Unified Requirements Modeling language, which is tool agnostic. This is the Enterprise Architect implementation that allows you to create a composite diagram, blow it up, and see the information at a lower level. Okay, does that answer your question? So the idea is we want to be able to do this, just like if you have Excel and you have a pivot table. You know, you want to be able to take one cell and have it represent an entire spreadsheet at a lower level. It's the same basic idea. And this can be as quantitative or as qualitative as you want it to be. It can be very detailed quantitatively. You can do algorithmic analysis, or it can simply be something which is a guide to management. So, okay, so again, we can visualize the goal conflicts. And now over here, you can see that not only can we visualize it, but when we go to marketing and we now create our marketing sheet that has our bullet items, which are the features for our product, we can now, in our model, we can connect the goals to the features. And so if someone says, who asked for that? We can backtrack, find out what the goal was, and then we can also determine who asked for it. Now, just to point out, we have multiple types of stakeholders because we have different kinds of goals. We have business goals and we have customer goals, right? The business goal might be, I want to acquire 5% of the market, business goal. A customer goal might be, I won't spend more than $50 for it. So the goals between customer and business will vary widely. And then you have to do a balancing act. This can translate it, for those of you who know it, I'm not sure you have a background in it in systems engineering, but there's a thing called the Q matrix, which is really the same thing in matrix form with numbers for different options, and you can translate this into a Q matrix. Okay.
Question?
Yes.
I'm a visual person myself, and I think with the question I have, couldn't you represent the same concept in an Excel file so you can manipulate and prioritize easier?
Can you tell by looking at a cell in an Excel spreadsheet who the stakeholder is who requested it?
You can write it down.
Okay, you could write it down. But it's not the same thing. It's like looking at the map of the United States and then looking at all of the states, each one in its own cell. You know, you don't quite see the same picture, I don't think.
That's a question I have.
Yeah,
because
so,
I'm trying to see.
yeah, so
manipulate and prioritize and
this can transform into an Excel matrix, which, as I said, was a Q matrix. So it does transform. But when you transform, you lose some of the visualization. And also, don't forget, we want to trace from the goal to the product feature. We want to do a tracing from goal to product feature. Okay. Okay. So we want to be able to, we have another story here, which is I want to be able to distinguish between functional and non-functional requirements. And I want to be able to do it in such a way that I can visualize what's happening. And also, I want to be able to map features to functional and to quality requirement. You can do this now, but it's very difficult to do. And for example, if you look at the URML and you look at SysML, they don't even support the concept of a product feature. They don't even have the concept of a product feature because they're so design-centric. Okay, so here's an example of a whole body X-ray scanner. All right, this is a whole body X-ray scanner. And I want to be able to move the stand and the table. Right? It's perfectly natural. Person's just a C-arm, big C-arm scanner, person's lying. I need to be able to move the stand, and I need to be able to move the table. So here we have a non-functional requirement, or a quality requirement. The stand shall move slowly and continuously to avoid discomfort to the patient. Right? We have a functional requirement that it will be possible to pan the table. And the stand base shall support swiveling, functional requirement. It shall be possible to perform a height adjustment of the table Again, feature of your product, functional requirement. And it should be possible to rotate the table, and it should be possible to repair the table without disassembling it. Again, a non-functional requirement. Functional, for those of you who are not familiar, are those that are features that impact the features of your product. And non-functional are those that are typically sometimes called quality requirements, like performance and maintainability. Yes?
What are the U and the M?
Okay, U is usability and M is maintenance. We're going with the ISO standard here. The ISO standard for quality requirements. We pulled it right out of the ISO standard. Okay, so we have both quality and functional requirements. And you'll notice, unlike SysML, where everything is a rectangle, I don't know why engineers, maybe that's why they call us blockheads, right? Because everything is always a rectangle. Every time you come up with a new language, everything's got to be a rectangle, right? And if it's not a rectangle, it's an Easter egg. So here finally what we're doing is we're using symbols so that you can look from 50 feet away, you can look and say that's a quality requirement, and that's a functional requirement. Okay.
I have a question.
Yes.
So in the agile kind of world, which, you know, with sort of features and stories, and this kind of modeling would sit, this is still kind of on top of almost the features in the agile. Like, how does this relate in an agile kind of descriptive world?
Well, it would depend. This is related to customer stories. You could use this technology to capture the customer stories. And every time the customer says, you know, if you do that, there's a potential hazard, you know, you got to watch out for that, you can capture it. Very hard to do that in a user story, right? And I'm not sure exactly how Agile is going to handle products where there's the potential for injuring a person. I don't know how Agile would handle that. Maybe downstream after the product was built, and then you'd have to go back and refactor half your features. But this is designed for upfront analysis. So maybe during the feature story capture phase, you could use this. Sometimes, though, even with feature stories, you have to do process modeling because the testers need to know the process in order to be able to generate test cases. Okay. Here's story number 3, identification of hazards and threats. So I went to one company and I said, what do you want to do? And they said, we want you to help us reduce the time to get this thing into the market. And I said, okay, when is your next big milestone coming up? And they said, well, we have to get all our requirements approved within 1 month. Okay? They had approximately 5,000 requirements. And I said, okay, it's going to take a while, and then on top of that, you have to do a hazard analysis on each of the requirements because this is a medical device. You see, even if it's software, if it touches the patient medical record, it's considered a Class 2 medical device by the Food and Drug Administration. So they said, okay, and I said, it's going to take you, we've estimated you can do about 4 to 6 requirements an hour during a sit-down review. And they said, well, we'll never make the date. We have several thousand requirements. And I said, very simple. Make the review criteria very, very simplistic. And they said, but then we might have bad requirements. And I said, take your pick. You want good requirements or do you want to pass the review? And then it just dawned on me, and I said, well, what about a hazard analysis? And they said, oh yeah, this milestone requires that we do a hazard analysis on all the requirements. And I said, well, how many people do you have here who do a hazard analysis? And they said, 1. And I said, we brought her into the room, and I said, how long do you think it takes for you to go through each of the requirements and study it? She says, maybe 1 or 2 hours. It's 4,000 hours. Anybody to help you? No, right? So anyway, that was one problem I ran into, and I very quickly left the building and figured I'd wait till the smoke settled before I came back. Okay, so anyway, here's an example of identification of hazards and threats. So you're sitting with, normally you would never do this because normally what you would do is you would put the requirements for your new system in, and then after the requirements were all done, you would do a hazard analysis or a threat analysis. Like, for example, you'd analyze the potential threat from logging in, that someone could hack in and bypass your login mechanism, right? You would do it after the fact. You have experts who do that. So here's an example of a phlebotomy process for drawing blood. So you're going to collect it in tubes in a specific order to avoid cross-contamination, and it's all written down. That's very nice. And then sometimes you can't find the forest for the trees. So what we want to do is we want to support hazard analysis. We call it danger modeling because we have two subclasses of danger. One is hazards and one is threats. So we want to be able to handle both of them, hazards and threats. And the system shall support mapping to hazards to danger or whatever. And the system shall support use case modeling or process modeling. Okay. So here's an example. I have process here. And then these are all different processes. And here are some of the hazards associated with the different processes. And here you see, this is, I don't know how well you can see it, but there's a hand being squeezed by gears there. That's a mechanical hazard. And here's a hazard, this is a biohazard over here for potential contamination. So here, for example, it says instrument malfunction, contamination of the sample. And here we see, for example, this is really hard to read, I don't know. It's maybe a little out of focus. But these are the different hazards. And then on top of that, I have requirements. Here's this is the equivalency of assay results across the platform. In other words, I want all the samples to have uniform results, assay results, or accuracy. And so what happens is now, for the very first time, we're capturing the hazards as we capture the customer process. We're not waiting to do an analysis at the back end. We're doing it at the front end. Yes?
But you don't necessarily show the relationship between the process and the associated hazard or hazards?
Well, here's the process.
But,
and here's the hazard.
Okay, the process in the center. Okay.
That's the process. The process here, if I can read it, is, I can't read this. This is sample processing. That's sample processing.
All right, and all the ones on
those are all processes that are included. So this is included. Okay. This is an extending. Extending means optional, and here's a requirement attached to that. Now, when you do that, you know, I always told my kids, if you bring me a problem, you have to bring me the solution, right? You can't just bring me a problem without a solution. So what we have here is we have this little shield. And so this little shield means mitigation. And here I have two kinds of mitigation. I have a requirement, which is called the mitigating requirement, meaning I have to add this requirement to my system to mitigate it against these hazards. But in addition, I found that very few people realize that a lot of mitigations are not through requirements, but through their procedural. The nurse will do this, then she'll do this, then she'll do this. And then we don't have to make any change to a medical instrument. We'll just put it in a procedure that the nurse has to follow. Okay? So we have here what are called procedural mitigations. So here I have a hazard, and I protect from that hazard with a functional requirement here, and this is actually a set of functional requirements. You see the little eyeglasses there, because there were too many to put on this drawing. And here are the set of mitigating procedures at a lower level. And I can actually show you this online if we do a demo later.
And what about the two other symbols with the R and the diamond with the R and the
okay. I'm glad you brought that up. R is a regulatory requirement. And this is a quality requirement that's regulatory in nature. And E is an efficiency requirement. No, environmental. Environmental requirement.
So there can be multiple categories.
Multiple categories, yeah. And we did not reinvent the wheel. We simply used those out of the international standards, the categories. So we have process, hazard, and mitigating requirements. Okay. So now the next big issue is use case versus process. Have any of you ever tried to use the UML to do process modeling? Have you ever tried to use the UML, Unified Modeling Language, to do process modeling?
Yes.
Okay. So one of the biggest problems is distinguishing between a use case and a process. A process is what happens in the customer environment, and a use case is the interaction of the system under study with the outside environment and the decomposition of that interaction, and they're totally different. So the process is what's happening outside, and the use case is what's happening at the interface and inside. And here, for example, we have AutoCaser DU Transportation. This says unload the truck at the loading dock. That is not a use case, unload the truck at the loading dock. This is a part of a process for the United States Postal Service. Okay. And here's move containerized mail to the loading dock. That is not a use case, it's a process. But we're showing it using a use case because it's the only game in town when you use the Unified Modeling Language, which is the standard language in use worldwide. So, and here we have a clerk, and here's a boundary, which is the area where you're going to unload the trucks. And this just doesn't work very well because we have process, and we want to have use case. And they both use the same symbols. So mail prep for the United States Postal Service is receiving letters in different forms, mail in different forms, and then you have to package the mail, and then you have to do various things with the mail. So from our perspective, a use case starts with the mail sorting system and how it starts to handle all that incoming mail. So, I had a lot of trouble with packaging engineers. This whole thing drove them nuts when I was doing a new mail sorting system for the Postal Service. Okay, so the system shall support the modeling of business processes. It shall support use case modeling, which is the functions of the system under study. And we want to use different notation for use cases and for business processes. Okay. So maybe something like this. Execute an examination, acquire images, and manage the patient. The patient is not inside our system, the patient is a process, right? Whereas executing an examination using a medical instrument is part of our system. Okay, so we have process and we have use case. So the question was, why not do all these things in a single language? So that's what the URML is. The idea to roll all this stuff up into a single language. How much time do we have left?
25 minutes.
Oh, good. Fine. Okay. So the idea now is we want a language for us, for the people who define the requirements for products, for the people who go and talk to business people and say, what are your needs? What are your goals? If you have a product, what is your product line? What are the variations in the products in your product line? And I need to be able to present these in a way such that when I go to the CEO of the company and I say, this is what you're getting, he says, that's it. That's what I want. As opposed to showing it to a software designer. So we have an abstract syntax. We incorporate various concepts, like the ones I've been talking about. Well-formedness rules, concrete syntax, and it's icon-based. One symbol for one concept. Everything is not a rectangle. In fact, I don't think we use rectangles for anything in this language. Okay. And we have semantics, construction semantics, or rules by which you build these things. And it's informal. That is that you can sketch with it just like Etch-a-Sketch. You don't have, you can be formal if you want to, but you don't have to be formal. For those of you who have a grounding in language theory or the concept of meta-modeling, there it is. Enjoy. Okay? So here, for example, we have a process, and we have two subclasses. Remember, one is an environment process, environment of the system, not environment of our environment, but environment in which the system works. And the other is your traditional use case. So we have that. And we have the concept of harm, and we have vulnerabilities, and we have things that trigger dangers. So you can use this, your analyst can use this for threat modeling as well as for hazard analysis. And we also have, well, this thing keeps changing on me. We have different hazard types: seismic, meteorological, biological, chemical, radiological, mechanical, electrical. We also have social. Social is cute. It's a little picture of a bunch of people kicking somebody. That's the social one. So someone asked me, well, what do you need that for? And the answer is, believe it or not, Siemens makes these cameras that can do detection of events. And so, for example, if there's disturbance on a train platform, let's say someone's been pushed off, or there's a mob scene on a train platform, you can use this to represent a symbol for a social event occurring as well, or crowd control, things like that. Okay, and then of course, it keeps escaping from me, we have two types of mitigations. Unlike the rest of the world, we support procedural and requirements mitigations. We've taken into account that very often mitigations are not built into our machinery, but they're in the way of the people who use the machinery. Okay, and we have different types of requirements, product features, and so on, and that's basically the meta model. It's relatively complete, and the thing I want to point out is, for the very first time, whether you agree with it or not, we have a formal relationship between a goal, customer goal, a business goal, a product feature, the product, a requirement, a hazard, a threat, and mitigations. You will not find that in any other modeling tool or language. And for the very first time, we can tell you that there is a relationship between a product feature and a requirement, which is something that's not available in any other tool. Okay, any other language rather. So this is an abstract representation of the meta model, and you can see we have processes, we have dangers, we have requirements, features, and goals, and then we have different kinds of stakeholders, and we've captured all of that. So we have this visual language, and you can walk into someone's office and sit down and start capturing things, and you don't need to write them down and then scratch your head and say who said what later on. You capture it right on the spot. Every one of the diagrams I showed you that was a URML diagram was taken from a real project. Okay. So we have a unique holistic view of systems. So we have, that's a toolbar from Enterprise Architect. Now the language is tool agnostic, but in order to test it, we had to do an implementation. So we said, what's the cheapest tool around? Naturally, of course, Siemens would be using the cheapest tool, right? So the one that was most in use was Enterprise Architect, which I think you can get the base product for $200 a pop, $200 a seat. So we did an implementation to test it in Enterprise Architect. So that way we were able to try it out on real projects. So we have system and process modeling. We have goal modeling. We have product line engineering, including products and feature modeling. And we have hazard analysis, including danger, including threat modeling, which is used by security people, and hazard analysis, which is done by hazards experts. And that's all part of this language. And here's an example of kind of like a roll-up of everything on a single diagram, although I wouldn't necessarily recommend this level of simplicity. So here we have an open window, and here we have a rising window which potentially could hurt a child. And here we have the child that's being injured. And here we have a little ambulance symbol, and we mitigate the danger by introducing a pressure sensor, which is a new functional requirement. And here we have a requirement functional that the window lift motor control shall intercept window movement when pressure sensor is triggered. And here we have a business goal that we're going to have child safety, and that goal was expressed by the parent. And here's a product feature, which is a pressure sensor, and here's a group of features, including the electric window lift. And again, we have the window lift motor here. And this is an external item, which is the window lift motor control, which is an external object that interacts with our system of interest. So that's basically it in a nutshell. And you can do whatever you want with these things, but I want to point out that this little guy over here, which now you can plug into a $200 tool, if you went to buy a product line engineering modeling tool, it would run you a minimum of $8,000. Free. Okay. I'm going to put somebody out of business anyway. I'm definitely not making money off of this. Okay. So here's some examples of the visual notation. Well, the way we did this is we used to do surveys. We would give people surveys and we'd give them multiple symbols and we'd say, which one do you think best represents the concept? The one we didn't go with, though, for actor was everybody wanted Arnold Schwarzenegger. But we decided not to go with Arnold Schwarzenegger because he was time sensitive. This was before the latest stuff in California came out, right? Okay, so you can recognize some of them. That's a boundary condition, the boundary between a piece of equipment and the outside world. This is an external server. And this little symbol up here changes based on the kind of server it is, whether it's a computer server, whether the external server is a business or whatever. This is a product line. This represents a product line. Some of these symbols have changed since this picture was made. Here's a stakeholder request. We even have, I don't know if I see it up there. Yes, we even have a symbol for putting an idea down. What other modeling tool have you ever seen that lets you capture ideas? So you can capture ideas. So it's kind of like the Etch-a-Sketch for requirements modeling. The whole idea was you can do it fast, you can do it very, very quickly, and it works. So we also went and we tried, instead of you having to type in, this is a hazard, this is a meteorological hazard, this is a biological hazard, this is a radiological hazard, we thought that we would do is make it easier for people by putting the symbols there, and when you drop one of these, it pops up and says, which one is it? If you don't like any of them, you can always go with uncategorized. So we have seismic, social, there's a little guy getting kicked in the ground. Oh, poor guy. Okay, we have mechanical.
Doesn't sound very social.
What?
Doesn't sound very social.
Unsocial, right. But remember, it is a hazard, okay? We have electrical, chemical, biological, and so on. And then over here, many of these you're probably familiar with. We have functionality requirements. We have efficiency, maintainability, portability. This is if you have something and we haven't figured out what it is yet. Usually I use this when two people are in a room and they both have an argument and can't decide what it should be, and then I just leave it like this. Okay. Usability and reliability. The R stands for reliability. However, we deal with so many projects where we're in a regulated environment. We added a little policeman in the lower left-hand corner which says this is a regulatory requirement, you better pay attention to it. Because in the past you'd have this long list of requirements and you couldn't tell which ones were regulatory and which ones were non-regulatory. So we put this in, and you can see the little policeman there. We got that. That's actually from the customs symbol. You know, if you go to an airport, that's the little symbol of customs. We stole it. Anyway, there we go. Okay. So here we have an automated blood analysis. We have a laboratory technician pressing the button on the analyzer, and here we have the product line, and here we have a use case for automatic blood analysis. We have two kinds of entities or objects that might be manipulated. One is atomic, and we use a little file cabinet to represent a composite where you can put other things in it, and we use a little letter to represent an atomic one. And here we have check sample integrity, and which requires that the system shall check samples for hemolysis, and that details the ASTM hemolysis test. And we have a regulatory requirement, which is that 99.99% correctness of the hemolysis test. Don't ask me what that means. This is phlebotomy, okay? And we have a solution that reliably tests blood samples for hemolysis, and that's this product feature realizes this goal. So that's basically what it looks like. And these things are so simple, you can even show them to a company officer. That's how simple they are. And he or she will understand it. Okay. So anyway, that's basically what it is. And regarding early feedback, we've used this now on several projects. And it's been very positive, mostly because people can understand it, and they don't have to be software developers using the UML to understand the symbols. Anybody can understand what it is, and they very quickly get into the spirit of it. And the goals, features, requirements in the same tool made it very, very fast to capture these things when they're throwing at us very quickly, and we have to capture stuff in a hurry. Product lines, features and requirements in the same tool, very positive. Also, a fallout is a product map. Everybody know what a product map is? No? Okay, so imagine you're going to look at Nikon cameras online. And imagine across the top, you have the different Nikon cameras in the Nikon product line. And down on the left side, you have the features. And going over, you have X's wherever the product has that feature. That's called a product map. And you get it for free when you do product line engineering. And I can show you what it looks like for the Chevy product line, because I did the Chevy product line in I pulled it off the web and did it using the tool. Okay, so some issues. We still have a few issues. We have fixed some bugs, because naturally, first implementation, we found bugs in it. And then version 1 was released. And we're still waiting for feedback on version 1, and I'm sure we'll have another iteration. We're currently missing clear guidelines for an interface between the URML and design-oriented languages like SysML. When I did the whole body X-ray scanner, I had to do it, but it was very impromptu. And the nice thing about SysML is you can connect anything to anything. So I was able to kludge something, but I had no clear guidelines to go on. What level of design should be connected to what level of requirements. So that's still an open issue. By the way, that's also an open issue even if you're not using this tool. What granularity of requirements to what granularity of design. Okay. Finally, the implementation of the UML based profile had problems because this was initially implemented as the UML language. These modeling tools support what are called profiles. And you can take the base modeling language and you can extend it with a profile. And because we were forced to use UML constructs and layer our stuff on top of them, we ran into some problems, which I won't go into here. But anyway, the problems we ran into were with deficiencies in the UML, the Unified Modeling Language. So we inherited some of the problems of the UML when we made this visual language. It's operational. One of the medical workers I was talking to said, for the first time I can see why there are so many issues with this step of the process, because the phlebotomist, we had the process whereby we do blood analysis, and she could never understand previously why they were having so much trouble with one step of the process. And then when we modeled this and you saw all the hazards associated with that one step, she for the first time realized, oh my God, look at how many hazards, potential hazards there are associated with this one step. So if nothing else, it may eventually get used for that purpose to holistically identify hazards and hopefully make our products safer. Okay, it also solves the tracing problem. How many of you ever have to do tracing from requirements to design to testing? Anybody ever stuck with that? Okay. You got it all in one tool now. You can go right from a stakeholder request to a business goal, to a product feature, to a requirement, to design, because both SysML and UML are in the tool, to implementation, along with identification of the variation points in your product. So If you have a product that's customer configurable, and the customer can do this, or he can do this, or he can do this, and you're creating a nightmare for your testing staff because you don't know what the legal combinations are, you can specify them using feature modeling. So in conclusion, and I don't know if I have a little time, I can give you a demo if I have just a little bit of time. It works. That's number one. And number two, why isn't everybody using it? And the answer is because we just finished it. So I don't know what people are going to start charging for this thing, but right now it's free for anybody who wants it. It's a plugin, and we only did one implementation for Enterprise Architect, which is made by Spark Systems. And the entry-level price for Sparks is, I think it's $200 for a base copy. And the only thing we ask of you, if you ping me with an email and say, I'd like it, it plugs into the tool. You have the tool installed, then this is a plugin. The only thing I ask of you is that you try it out and then send me your comments or feedback. Okay? Okay. So now it's time for questions. And if we have a little time after that, or maybe after the meeting's over, I can give a demo for 5 or 10 minutes. Okay. Yes?
Okay, you primarily use very large, complex projects. What if you need to do something simpler? Same sort of scenario? Would you probably dummy down the diagram?
I don't know. It's up to you. I think I've never seen a really simple project, because I've seen projects that start simple, and they say, well, this is a throwaway, and they say, this is great what you did. Now we're going to use it for the whole corporation. That's what happens to your throwaway. So I don't think personally, I don't even think there is a such thing as a small project, really. But for sketching, why not use it like an Etch-a-Sketch? At least, the very least, it's a good way to communicate your ideas to management, right? Right. So, yeah.
What is the competition to this product? Like, what are some of the leading companies doing right now?
There is no competition.
Right, you said it's like a group of tools they use, so it's
if you want to buy a product line engineering tool, you need Pure Variants, which I think is $8,000 a seat. If you want to do goal modeling, there are no commercial tools for goal modeling. You have to go and buy a research tool and download it, and then of course you have a firewall because it's not connected to anything else. If you want to do hazard and threat modeling, there are no equivalent tools on the market. The only thing you have is Microsoft does have a very simplistic threat modeling tool, which is useless unless it's an expert using it. Regarding hazard modeling, hazard analysis like failure mode effect analysis and things like that, there are tools, but they're very specialized, and they're designed for the expert doing the analysis. They're not designed to capture potential hazards when talking to the subject matter expert. So there is no equivalent tool. Okay. So the only one I know of is for product line engineering that's commercially available, and that's made by Pure Variants, and I think that's about $8,000 a shot, maybe more. Okay. Yes?
I'm dealing with the investment banking applications domain, and we frequently see a many-to-many relationship between the stakeholder requirements or goals and product features, product requirements. So I wonder whether this language implies any particular type of relationship, or it's flexible and it can handle many-to-many relationship or whatever.
Well, the tool itself, the meta model, defines what a relationship is. So for example, if I have a product feature and I have a requirement, the requirement explains the product feature or refines the product feature. So there are these relationships, but in terms of many-to-many, there's no reason why it does support many-to-many. And you can add cardinality to the lines if you want to. There's really not an issue with many-to-many. So 5 stakeholders could request one feature, right? 5 stakeholders could have the same request. Nothing wrong with that, and that's perfectly fine. Yes.
What sort of user training do you have to do for people to get comfortable with the icons?
None. There is no training. You just turn it on and start using it. There is a little user guide, a draft of a user guide. The problem that most people will have is not the tool itself is Enterprise Architect. So then there's the issue of learning Enterprise Architect, which is a modeling tool.
I meant for the end customer, the stakeholders who are looking at the document, would they need training in terms of understanding those?
I showed you what the symbols are. I can't imagine, I mean, if you see a person with their hand being mashed, and then you see a mitigating requirement that the thing shall not mash their hand, I don't know. If the stakeholder needs more than that, then maybe you got the wrong stakeholder. I don't know.
So
So-
in practice, you did need training.
Excuse me?
In practice, they were able to consume that without any problems.
I've showed this to doctors, nurses, electrical engineers, just about anything you can imagine, managers, and I've never had an issue. I'm sure there's going to be a first time, and it might take 5 minutes to explain what you're doing, right? So,
Yeah, I mean, I think some of it's about experience of, I remember like somebody just saying to me, like, rational for unified, use cases. I have to learn rational speak to talk to you these days. And, it's kind
Right.
of like, well, okay, that's one way to look at it. We're trying
Right.
to,
everything here is English. A hazard is a hazard, a threat is a threat, a product feature is a product feature. A product has features. These features are explained by the requirements or refined by the requirements. And the requirements may have hazards associated with them, and the hazards are mitigated with either mitigating requirements or with mitigating procedures. So, and we have processes, and we have use cases. And a process is something the customer does. It's the environment in which your product swims. And a use case is a hierarchical decomposition of what the system's going to do.
I guess the demo might also answer, some of the questions, very illustrate, how to put together one.
I mean, I do have, I don't know if we have a little more time later, I do have the Chevrolet product line models, and you can take a look at it. But okay, thank you.
Okay, well, thank you very much.
Thank you.